Hello everyone, in this tutorial I'm gonna share with you about the offset list. So the first thing you might be asking that, what is the offset list? How can we apply it? Alright, before I talk about the offset list, the first thing I want to clarify that offset list is not the excel list, but it's calling to the excel list. As usual, let's take a look why we are doing the lab. As you see here, in this topology, total we have 5 router 1 to router 5. I already configured the IP address as well as RIP version 2. Router 1 has a looper address 1.1.1.1 and router 5 has a looper address 5.5.5.5. We just focus on this looper address. Alright. Based on this topology, from router 1 perspective, to reach router 5, there are two different routes. You know that RIP metric calculation is the hop count. Lowest hop count is the best route. Okay, let's count here. If we go from this way, 1, 2, 2 hop count away. What if we go from this way, 1, 2, 3, 3 hop count away? Router 1 will definitely choose this way. Alright, let's verify it. Show IP RIP database. 5.5.5.5 is in the database table. What about the routing table? Show IP route RIP. 5.5.5.5 is present in the routing table. 2 hop count away. 10.1 or 12.2 is router 2. Let's move on router 5. Show IP RIP database. 1.1.1.1 is in the database table. Show IP route RIP. 1.1.1.1 is present in the routing table. 2 hop count away. 10.1 or 25.2, which is router 2. Alright, now we try to do a pin test between these looper address. Pin 5.5.5.5 source 1.1.1.1. Pin is successful. Trace route 5.5.5.5 source 1.1.1.1. Router 2, router 5. This is the outgoing traffic. So what about the incoming traffic? We move from router 5. Pin 1.1.1.1 source 5.5.5.5. Pin is successful. Trace route 1.1.1.1 source 5.5.5.5. Router 2, router 1. This is the incoming traffic for router 1. Okay, I want to clarify one thing for the incoming and outgoing traffic. Let's say I'm router 1, you are router 5. The outgoing traffic sending out to you from your perspective, that is the incoming traffic. The outgoing traffic sending out to me from my perspective, that is the incoming traffic. That is why earlier I verified the outgoing traffic for router 5, which is the incoming traffic for router 1. I believe you got it. Alright, please take a look on this situation. Let's say this is a 10G lane, this is a 40G lane. Now the incoming and outgoing traffic for router 1 and router 5, primary link is 10G, secondary link is 40G. Normally, in our network, 10G, 40G, which link do we prefer? Definitely 40G, right? Okay. Based on this topology, what are the situations we use 40G as a primary link? In case this link down, or what if we go from this way more than 3 hop count? Then we use 40G. But in our case, we don't shut down the link, we just increase the hop count. This kind of situation, we can use the offset list. Okay, configuration part is easy peasy. Config T router RIP. There is a command offset list. Add or subtract offset from RIP metric. But the thing is, we can only increase the hop count. We cannot decrease the hop count. Okay, offset list followed by the access list. If we define 0, it will select for all node. In our case, we just focus on router file loop at fight. Let's define the access list number fight. In, out. What do we need to apply here? Alright, let me explain the concept of in and out route policy control, inbound and outbound route policy control. If we control the incoming route information, it will affect the outgoing traffic. If we control the outgoing route information, it will affect the incoming traffic. It's not only for the RIP, but also for the EIGRP, OSPF, ISIS, BGP, as long as we use in and out route policy control. Now, we want to affect the outgoing traffic for router 1 to prefer the 40G lane. We need to control the incoming route information. Alright, how many hops do we need to add? Let's say we add 1, total will be 3. The outgoing traffic will be load balancing. Adding 1 hop count is not enough yet. What if we add 2? Total will be 4. Then the outgoing traffic for router 1 will always prefer the 40G link. Okay, which interface do we need to choose? We need to choose the interface Gigabit Ethernet 0/0. We cannot choose Gigabit Ethernet 1/0. If we choose this interface, total hop count will be 5. You got it? Gigabit Ethernet 0/0. Access list 5 is not defined yet. Access list 5 permit fight do show run by session router RIP do show run by session access list. Okay, we have access list file. This access list file is being called by the offset list. There will be a 2 hop count increase if the IP address is matched with 5.5.5.5 that is received on this interface Gigabit Ethernet 0/0. Do show IP protocols. You see here, incoming route in Gigabit Ethernet 0/0 will have 2 added to matrix if on list 5. Do show IP RIP database. 5.5.5.5 is in the database table. Do show IP route RIP. 5.5.5.5 is present in the routing table. 3 hop count away. 10.01 or 13.03 is router 3. Let's try to do a pin test. Do pin 5.5.5.5 source 1.1.1.1. Pin is successful. Do trace route 5.5.5.5 source 1.1.1.1. Router 3, router 4, router 5. Now, the outgoing traffic for router 1 will always prefer the 40G link. So, what about the incoming traffic? The incoming traffic for router 1 wishes the outgoing traffic for router 5. Let's move on router 5. Show IP route RIP. 1.1.1.1 is present in the routing table. 2 hop count away. 10.01 or 25.2 is router 2. Pin. Trace route. Router 2. Router 1. For router 5, outgoing traffic is using the 10G lane. Incoming traffic is using the 40G lane. That is the asymmetric routing. Okay, we can do the same things that are applied to router 1. We can increase 2 hop count if the IP address is matched with 1.1.1.1 that is received from this interface Gigabit Ethernet 1/0. But we won't check any configuration on router 5 for some reason. Maybe in the exam, we are not allowed to change any configuration on router 5. Or, to give you a real world example, especially for the service provider network, let's say you manage router 5, I manage router 1. You told me that you don't want to control any route information from your end. If I want, I can control whatever from my end. In this kind of situation, we need to control the incoming and outgoing route information from one side. Alright, let's go back to router 1. Router RIP offset list. For router 1 loopback 1.1.1.1, let's define the access list number 1. If we control the outgoing route information, it would affect the incoming traffic. We add 2 hop count, gigabit Ethernet 0/0. Access list 1 is not defined yet. Access list 1 permit 1.1.1.1. Do show run by session router RIP. Do show run by session access list. Okay, we have access list 1. This access list 1 is being called by the offset list. There will be a 2 hop count increase if the IP address is matched with 1.1.1.1 that is sending out on this interface gigabit Ethernet 0/0. Do show IP protocols. Outgoing route in gigabit Ethernet 0/0 will have 2 added to metric if on list 1. Do show IP RMP database. 5.5.5.5 is in the database table. Do show IP route RMP. 5.5.5.5 is present in the routing table 3 hop count away. 10.01 or 13.03 is router 3. Let's try to do a pin test again. Do pin 5.5.5.5 source 1.1.1.1. Do trace route 5.5.5.5 source 1.1.1.1. Router 3, router 4, router 5. Okay, we move from router 5. Show IP RMP database. 1.1.1.1 is in the database table. Show IP route RMP. 1.1.1.1 is present in the routing table 3 hop count away. 10.01 or 45.4 is router 4. Pin 1.1.1.1 source 5.5.5.5. Pin is successful. Trace route 1.1.1.1 source 5.5.5.5. Router 4, router 3, router 1. Now, the incoming and outgoing traffic for router 1 and router 5, primary link is 40G, secondary link is 10G. Alright, no surprise, that is the expected result. That's all for today's tutorial. I believe you now have a better understanding about the offset list, incoming traffic, outgoing traffic, in and out route policy control. If you like this tutorial, please subscribe to get the notification for the upcoming tutorials. Thank you. Catch you next time.